So if I use a 90% confidence interval, the 90% confidence interval would be something like this, right? A 95% confidence interval, I'm exaggerating, but would be something like this. And they all have the same mean in the middle. Of course, a 98% confidence interval will have, I'm exaggerating, will have these bounds. So as the percent increases, the margin of error increases. This is the margin of error for a 90% confidence interval. This is the mean right here, X bar, right here in the middle. This is the margin of error for 95%. And this is the margin of error for 98%. So if I'm 90% confident, then I have a narrower interval, but smaller error. If I want to be 98% confident, then I'm enlarging the interval. I know I'm confident, 98% confident that somewhere here between these two bounds, I will get the population mean that I don't have, but the margin of error is bigger. So as the margin of error increases, the confidence level increases. And what is the margin of error made of, right? Is that T alpha over 2, S over the square root of n. So this piece, now this doesn't change, right? This changes because it depends on alpha, right? It depends on if I am in the tails with 10%, 5 and 5, or if I'm in the tails with 2.5% because this is 95, or if I'm in the tails with 1% because this is 98. The tails here 1% and 1%. So this changes, but the standard deviation does not. And one other comment I have, the larger as I increase n, this is in the denominator, as this is bigger and bigger and bigger, as we noticed, this is smaller and smaller and smaller. We had here 26,000 blah, 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 and the margin of error was very small because the sample size was big. So when the sample size increases, the margin of error decreases. So this is an analysis for this problem. Okay, so who would like to take part A and determine the 98% confidence interval with 23 people? Who will take part B, 98% with 12 people and 90% with 23 people?
First one.
Who is taking the first one?
Michael.
Michael, thank you very much. So who's taking part B?
I'll do part B.
Thank you. And who's taking part C? So A was Michael. B was it Emily?
No, Sasha.
Sasha, sorry.
I can do C though.
And who's that, Money or?
No, that was Emily.
Emily, thank you. Emily K or Emily V?
Emily V.
Emily V, thank you. V from Victory. So the first one, it's 98% with 23. The next one is 98% with 12. And the last one is 90% with 23.
Okay, I have the answers for the first one.
For the first one, I'm ready.
The lower bound is 102.7.
1
102, 102.7.
Yes, because they want one decimal place. Okay.
And the upper bound is 115.3.
Good. Great job.
I got it.
I'm ready.
So the lower bound was 99.584,
So 5/8, so it's 6. Yes, comma.
and then the upper bound was 118.42.
So 4. Perfect. So 99.6 and 118.4. Great job. Good. So let's analyze this question first. So let's stop sharing for a second. So see what happens when the sample size decreases, the margin of error increases. When the sample size increases, the margin of error decreases. So here the sample size went from 23 to 12. So what does that mean? It means that the error is bigger. So remember the X bar is 109. So with n equals 23, we got the interval 102 to 115. But I decreased n, which means it increases the error because n is in the denominator. If I divide by less people, I get more here, right? So that's why this is a wider interval than this one, because here the margin of error is bigger than in this interval. So now let's see how they want us to interpret. As the sample size decreases, the margin of error decreases. True or false? As the sample size decreases, the margin of error decreases. True or false?
False.
False, of course. As the sample size decreases, the margin of error stays the same. True or false?
False.
Of course. As the sample size decreases, the margin of error
Increases.
That's it. Yes. It's the formula that tells us. We don't have to think twice about it. Yep. Okay, so the last one, do we have the 90%?
Yeah. So the lower bound, I got 104.7.
Perfect.
And then the upper bound was 113.3.
Good. So 104.7. I'm typing in the air. 104.7. Again, 104.7. Third time is a charm. Okay, and 113.3. Okay. Great job, all of you. Thank you so much. So now let's compare. Compare the results to those obtained in Part A. How does decreasing the level of confidence? So we decrease the level of confidence right here from 98 to 90. From 98, we decrease the confidence level to 90. Okay. So for the same number, we're not talking about the second one. We're talking about comparing this to this. Same number of people or the same sample size. So what happens when I decrease for the same sample from 98 to 90. So for the same
Did
sample,
the error increase?
so when we decrease, no, the error decreases. So the 98% interval is this, and 90% is that. This always has to be larger. See? 102 to 115. The 98 is this. From 102 to 115. 102 to 115. The 90 is this. From 104 to 113. Narrower. So this is 104 and this is 102. So maybe I should show it again here. So the 90% is this interval from 104.7 to 113.3, and the 98% starts at 102.7 and goes to 115.3. I know I'm exaggerating, right? So when I increase, or in this case it was a decrease from 98 to 90, when I decrease the confidence level from 98 to 90, I decrease the interval and the margin of error is smaller. E here is smaller because it's the distance between the mean and 113. Here's the distance between the mean and 115. So the margin of error is bigger here. Is that clear what I'm showing?
Yeah.
Okay, so let's see what they want again. As the level of confidence decreases from 98 to 90, the size of the interval decreases. True or false?
True.
True. As the level of confidence decreases from 98 to 90, the size of the interval stays the same. How come? That's not possible. As the level of confidence decreases from 98 to 90, the size of the interval increases.
False.
False. Yes, this analysis is very important. Okay. Should the confidence intervals in part A through C have been computed if the population had not been normally distributed? No, the population needs to be normally distributed because each sample size is less than 30. So we have 23, 12, and 23. The magic number is not fulfilled, is not complied with, so we should not. We did for the sake of the argument. Okay, oops. I'm sorry, I already kept you over. I'm so sorry. I'm so sorry. I will have to